Hello and welcome to another lesson. In this lesson, you're going to learn how to create a box plot in Python. So we are going to use the lumpy library to determine quartiles and the matplot library to generate a box plot. So Python can be a great tool for creating a box plot. Python can not only generate a vertical box plot, but also a horizontal one. Below is an example of a program that generates a box plot of one variable data inputted by a user. So the first thing that we have to do is we have to import numpy, and we're just importing this np library from numpy. And then we also have to import the matplot library. So the way we do that is we type this in matplotlib.pyplot as plt. Okay, so this is the way to import the matplot library, and this allows you to plot different kinds of graphs. Okay, so not only box plots, but bar graphs, histograms, and so on. So what we do next is we define a function that calculates the quartiles. Okay, so the first quartile, second, and third. So in order to calculate the first quartile, we use this function here. So np. So this is from the numpy library. np.percentile, and then in parentheses data comma 25. So this is the 25th percentile or the first quartile. Then the second quartile, also known as the median, is calculated using this function here, and np.percentile data comma 50 in parentheses. Third quartile or the 75th percentile, np.percentile, and then in parentheses data comma 75. And what this function does is it returns the first quartile, second quartile, and third quartile of the inputted data. So then what we do is we define the main function, which prompts the user to enter a set of data. And so this is what the prompt is. This is what the program will display. It will say enter a set of numbers separated by spaces. And whatever this user enters is going to be stored in this data underscore input variable. And so then what's going to happen here is the data is basically going to be sort of like so stored by Python. The values will be taken from basically the list. It's assuming that the values are floating point numbers, and it's basically going to try to create a map. Okay, because a box plot is kind of sort of like a map. It's an arrangement of the percentiles, the 25th, 50th, and 75th. So what the program does next is it calculates the quartiles. Okay, so this function is used to calculate the quartiles, and then the quartiles are stored in Q1, Q2, and Q3. Okay, so the function returns 3 values, and those 3 values are stored in these 3 variables in Q1, Q2, and Q3. What this program also does is it actually displays what the quartiles are. It displays what the 25th percentile is, so quartile 1. It displays the median, which is the 50th percentile, and also displays the third quartile or the 75th percentile to the user. And finally, what it does is it displays a horizontal box plot. So in order to make the box plot horizontal, because by default, the box plot is actually vertical. So this command is used to display a box plot. So plt.boxplot, and then in parentheses data, comma. So the vertical vert, we have to set equal to false in order for the box plot to actually be a horizontal box plot and not vertical. Here we're setting the title. So plt, so plot.title, and then in parentheses, we're just going to call it horizontal box plot of entered data, but you can really give it any title that you like. plt.xlabel. So this we're just labeling the data. So this we just have some values here, just an arbitrary name, but any name could really be used to describe the one variable data. And then finally, this function, this command here, is used for displaying the box plot. Now, in most programs where the user has to input data repeatedly, this kind of structure is required. Okay, this if, and then there's underscores, two underscores name, two underscores again, equals, or the comparison variable, not variable, operator, sorry. And then we have main followed by, so before and after there are underscores with quotes. This type of structure is needed in many Python programs that require input from the user. So breaking this program down in detail. So I've mentioned about importing the libraries. Okay, so lumpy, this library is used for numerical operations in Python. We use it here to calculate percentiles along with the quartiles. And then matplotlib.pyplot. So this library is used for plotting graphs and visualizations. We use it to create and display the box plot. So here we have parts of the code. So for the function calculate quartiles that's defined, the argument here is data. It's a variable. It's a list of numerical values that the user enters. The purpose of this function is to calculate and return the first quartile, the median, and the third quartile. So Q1 is calculated as the 25th percentile using this command and this function here that I've already talked about. Q2 is the median or the 50th percentile, and it's determined calculated using this function here. And then Q3 which is the 75th percentile, is calculated by using this function here, np.percentile, and it acts on the data argument. So this I've already discussed, prompting the user to enter a set of data. The user is prompted to enter a set of numbers separated by spaces. So what these commands do, and there's functions part of this as well. So reading and parsing input. So data underscore input dot split, and then followed by parentheses, splits the input string into a list of strings. Okay. So originally, it's actually just one string. When the user enters the data, that's just treated as a single string. Okay, almost like a sentence. This map, and then in parentheses, float, comma, data underscore input dot split, and then to parentheses here, it converts each string in the list to a floating point number. Okay. And so then the list function converts the map object to a list of floats, which is stored in the variable data. Okay, so there is a conversion from a string to a list that takes place, a list of just numbers. So first calculating the quartiles and storing them in Q1, Q2 and the Q3 variables, displaying the percentiles. And then I've talked about this already, displaying the box plot. I've talked about how to make it so that it's vertical and not horizontal, how to add a title, how to add a label for the variables. Oh, well, it's a single variable data in this case of whatever that variable is. It could be marks, for example, or ages or whatever it is. And so in summary, this is how the program executes or works. There's input first. The user has to enter a set of numbers separated by spaces. There's processing. The input string is split into a list of numbers. The quartiles are calculated by using lumpy. And then the calculated quartiles are printed. And finally, a horizontal box plot of the entered data. It's generated and displayed using matplotlib library. So the functions in that library. Okay, so let's have a look at how this actually looks like. So when we actually run the code, what does the box plot actually look like that is generated? So I'm going to run this program. And so we can see it says enter a set of numbers separated by spaces. So that's what I'm going to do. So 2, 4, 6, 8, 10. And then let's go with 12. Maybe I'll add some more. 14, 16, 18, 20. Okay. And then enter. Or return if you're on the Mac. So this is what is displayed. So the quartiles are calculated and displayed. So Q1, 25th percentile is 6.5. Q2, the median, the 50th percentile says it's 11. Q3, the 75th percentile is 15.5. What we also get is we can see a labeled box plot. So there's a title, and then the variable is also labeled. So we look at, so the 25th percentile is Q1, so it's 6.5. Okay, so it has its own way of calculating this, which might be a little bit different than what you've learned in this course. As normally we would think that based on the data here, that our median should be, well, yeah, so it's actually, yeah, the median is, yeah, it's calculated the way we expect. It's the average of 10 and 12. Because there's two numbers in the middle here. So that's 11. So that's the 50th percentile. So now let's look at Q1. Now the way Q1 is calculated, it's 6.5. So it's not calculated exactly like we're used to in class, because we would basically split the data in half like this, and it would just really end up being 6. But here it says it's 6.5. Okay, so it has a different way of calculating it. Then same thing for Q3 or the 75th percentile. When we split the data in half, and then we look in the middle here, it's actually 16 would be Q3. But it's close enough. It just has a different way of calculating it. Okay, and so yeah, so that is the way to create a box plot in Python. Thank you for watching this video.